Originally, the AI in 1955, this was the somehow definitions or the things which it wanted to do, which is not very much relevant now, at least not in this form. And today is in this form. I'll show you it so you can see the flags. Probably from down up is easier. So we have machine vision or image recognition, so as a vision, or robotics, or planning, scheduling, optimization, expert system, we will talk about it, speech to text, text to speech, translation, natural language processing, and we have deep learning, machine learning. So AI now are mainly, these are the branches of AI now at this. So this sort of actions which we do in AI, we call it part of AI. The same, this Copland, he has divided AI in 3 or 4 really different types. Strong AI is the one which we call it humanoid, and we want it to be a level that can understand, talk to us, or behave like a human. Applied AI is like the face recognition and things which we can like these self-driving cars or something like that. Novel AI, which I don't know if it's right pronunciation, is to mimic an animal, at least to make it to the level of even a virus or a small ant or animal. That if we can make a computer to do something intelligent to the level of animals. And cognitive simulation is a different different thing really, but it mimics the theories of the brain to check if this theory about mind is correct or not. So if you have a theory, we can set up a program to use the input and output and check if it's the same as our brain, that theory. So basically, nowadays the AI is somehow is addition, is extra to any program, which normally the easiest one are these Python, or Python is the best now, considered the best software for machine learning as a whole, machine language. But as you can see, even that is not, well, it depends on what level you want to use or whatever you want to use, or which one. Okay, then we start with different type of AI, which was practiced, and it is now, but some of them getting a bit out of date really, but or out of favor, not out of date. It's out of favor. Expert system was one of the best or first type of software they used. Basically, expert system is very simple system. It's a set of what if. We have an expert on the right side, and we have a simple user, if you call it, on the left side. So an expert teaches the computer what to do exactly, so when this happens, what to do. And the machine learns about, okay, situations, different situations, so in each situation what to do. So when this normal person uses the computer can help him make decision. For example, some simple system they use, for example, was in power plant or factories like cement factory or something like that. In refinery, you have a lot. In that you have to close and open valves, a lot of valves. Okay, but it depends on the situation. So pressure goes up, so you open this valve, and you have, when something is enough, close that one. So it's an expert he uses these valves all the time. It's an operator computer. So when you feed back all these levels to computer, so a computer sees the pressure all the time, and she knows the valve situation. You change it because of that. It will learn that in this situation you have to close the valve. In that situation you have to open it. You have to do this or that. When it's only 1 or 2 or 3, it's easy. But when it's about quite a lot, and you have to look at all these gauges at the same time, that becomes a bit difficult, and computer become better than that. The other one is in medical. They use it quite a lot, the expert systems in medicine. In medicine, they teach, for example, this mycin is a program. So it's basically it's a if-then structure, simple. If this situation, what to do? In this situation, what to do? So as a program, it's so easy. There's nothing in it really, but it's the situation that we have to feed it more and more. Mycin, for example, achieve a high level of performance. It operated on the same level of computers of humans, specialized in blood infections. So what it does, from the blood infection, it can tell you what's wrong with the patient from the blood test, and it becomes almost to the same level of a specialist, better than normal GP computer, because it has more data, more available in mind, remembers, oh, this situation is because of this, because of that. For example, in MRI, we have this problem. MRI, you have a lot of data, so many pictures of the brain, and you have to look all of them at the same time, because it's really 3D thing. And in one case, for example, the doctor, they fed all this to computer. And in one case, the doctor saw the computer result is different from what he thought. Then he asked the computer, why you decided this? And it gave a result. One of the photos of the patient, that so-and-so patient, had this situation, and he had this problem. And the doctor realized, oh, yes, that's right, if that's the case, because I didn't know, I forgot. So basically, today, I don't know, because this information which I'm telling you, this was about more than 10 years ago, 15 years ago. Maybe today they can rely on computer, but so far, they didn't rely on computer to make decisions. It just helps them to be sure that computer also says the same thing, okay, that's it. If both of them agree on the same thing, that's for sure. That's it. Go ahead. But it can be really in this type of structure, which is expert system, is very little amount of error really is there. So it's not a problem. But the limitation of expert system is that it doesn't have common sense. I'll give nonsense answer if you want, because that's not part of the if. I mean, it only knows things that if this is situation, what is the answer? But if there wasn't anything there to know if it's there or not, it cannot make decision, of course. The good thing about it is that it can work with humans. So you can ask why you did this, it tells you, or also you can ask this limitation under these circumstances, give me the answer, it gives you the answer. So because the programming is so easy, it's if and so, if then. So three type of inputs it has: knowledge, rules, if and then, we call it rule, and then separation of knowledge and inference machine, because the program is something and knowledge is different. So we can correct the engine, the search engine, make it faster, better, but information is there intact. And and the knowledge as the key to expertise. The knowledge itself should be given by an expert, somebody who knows. If somebody doesn't know, cannot give the information, otherwise it would be wrong decision will be made. And that's why it's called expert system as well. So that's with expert system. If you have any question, expert system. Fuzzy logic, it's one Iranian, Lotfizadeh, University of California in 1965. He suggested this word, fuzzy logic. Interesting. The problem with computer, as you know, is 0 and 1, and fixed numbers, really. So it's either yes or no. You can't say how much percentage, the possibility of this or how possibility of that. So when you want to, but in real life, we are all considering possibility. I mean, the chance of now the light turns off by itself or by the grid or whatever, it's a chance. It's not 100%. You can't say for sure that the light will not go off. It can go off. But we say, no, the chance is 1, 2 in million or whatever. Fuzzy logic basically is where situations you can say some. So some people are tall, okay? What you can say. You say, okay, I put it this way. The normal logic is all Iranians are tall. Ahmed is Iranian. So you can say that certainly Ahmed is tall. Certainly. Of course, if the data is right. But from the structure, from the sentence, that's it. When you have all of this has this feature, and some part is part of that feature, so certainly it has that feature. That's it. But when you use some, the word some, or percentage, that's a problem. You can't say. Some of Iranians are tall. Ahmed is tall. Can you say that he's Iranian? Or can you say that is he tall? You can't say. So you can say some, or Ahmed may be tall. So that by itself is a logic. Fuzzy logic is mainly deals with percentage, and normally, if you know this Bell function, which is the statistics, the possibility of that being that. So it's mainly like that. It's not something special about it. In fact, most of the as the example we said, for example, the scissor or hand, it will tell you the possibility is about 50%, 60%. This is the answer. So I'm going is right. That's fuzzy logic. So and we are using almost fuzzy logic. Probability, yes, always works.
It gives probability as a percentage.
Not only gives, it deals with probability. So if we have an input as in probability, what happens to output, and how to deal with probability. Yes, it's the mathematics of probability.
And it gives you how to.
Well, this is an example, another example. Yeah.
And it helps you to improve it. So if you're
no, it's not improve it. It's only tells you how you can say what you can say. What you can say simply here in Zab, for example, some school teachers are smart. Ali is a teacher. Can you say Ali is smart, or can you use it or not? Or you have to say Ali may be a teacher smart, something like that. So that's it. That's the logic. I mean, what you can say, what you can deduct from that to be sure is correct. I mean, the way you say it, it's important. For example, Ali is a teacher, so you can say he's not a student. For example, because we are either teacher or student at school. So some information are there. I call it ambient information. Information which is probably is not set there, but you know. We call it common sense information. In fact, this is a problem with deaf people. They lose a lot of this ambient information, things that we take it for granted, that we know. Some sentences are like, for example, here, I'm saying that Ali is a teacher, so he's not a student. So that wasn't part of the sentences before, but we know.